New setting. Welcome back, chemistry fans. We are going to go over your warm-up. So let's jump right into it. This is something that we covered last class. Hopefully it rings a little bit familiar to you. So we'll jump right into it here. Let's find it. It is going to be right here. Okay, so here we go. First question. It's asking us to draw the Y-shaped graph. Okay, so this is the state of matter. So I will resketch this for you. You can go back to your notes. It's pretty simple. So we would have pressure, and we would have temperature. Out of the origin comes these lines, and then we label them with solid, liquid, and gas in this clockwise fashion. Right down here on the first line that came out of the origin, that's where sublimation and deposition is occurring. Freezing and melting is occurring in between the solid and liquid, and vaporizing and condensing is what is happening in between the liquid and gas. In the center of this is where we would have our triple point out here at the far right. This is where we would have our critical point. That is the hottest temperature at which liquid can exist on its own. Sounds like kids are coming in. Hang tight. All right, so here we go. Now we're going to draw our second graph, the exothermic reaction. So in an exothermic, it starts out high and it ends low. The reactants are on the left, the products are always on the right. The difference between the starting and the ending point, that's where we need to focus. That is our heat of the reaction. The difference between the reactants and the top point, that is our activation energy. And if we had a catalyst, it would reduce that activation energy. It would lower that and make the time a little bit faster. Okay, last question is getting us to a math problem. So here we go. What is the mass? I'm sorry, what is the mass of the water that's going to be heated? So we need to know our formula. Heat is equal to mass times specific heat times the change of temperature. And change of temperature is the ending minus the starting temperatures, the final minus initial. So if I have my mass of, that we're not knowing, sorry, if we have our heat, it would be 2825. It is equal to the unknown mass. The specific heat is 4.18. The difference between those temperatures is 25. So it went from a final temperature of 25 to 50, and it went down to 25. That makes it 25. So I am now going to do a calculation on that one. So 2825 divided by 4.18 divided by 25, and that gives you 27. The mass would be 27 grams, which is, Justin, right over here, is the same as 27 milliliters. All right, that's everything I wish to share with you. Sorry about that call out. Someone was here. I'll talk to you soon, and I hope that you have a great spring break. Bye-bye.